All right, so let me go and update our code a little to be, I think what I have in the actual code. I mean, update the board to reflect our code. But we need to start thinking about how we're going to remove an item. Points to, what's it, 13. Am I off the board? No. Okay, so we're going to do this. And then we'll have mtail. Oh boy. Actually, we shouldn't have that yet, so let me fix this up even more. Okay. And we're going to call remove. And assume that this means remove first. Remove the first element in case there's multiple of them. And let's remove the, let's make this easy on ourselves. Let's remove 75. Maybe not as easy as it looks. Let's do the easiest case. I take that back. 19. There we go. All right, so we want to remove an element. What's the first thing we need to do here?
Find it.
We need to find it. All right.
So we can take what we already did for contains and copy it over.
We're going to copy it mostly over. I'm going to go ahead and do this one for you because it's actually, I think it's hopefully straightforward. And rover get val does not equal val. So, while rover is null and the vals are not equal, go to the next one. And then if rover equals null, return false. If we did not find, return false. Rover now equals the node we need to delete. Okay. All right, so wrote that out real quick, but let me make sure everyone follows. Node starts at head while rover has not gone to the end of the list, aka it's not null, and we haven't found the value. Keep iterating rover until you either get to the end of the list or until rover points to the node that contains the value you need to delete. If rover is equal to null at this point, that means we went through the whole list. It is not in the list. We return false because we can't remove something that doesn't exist. So that's the easy one. Just wanted to set that up for you. Now, let's say rover does not equal, whoops. Rover equals the node we need to delete. Much better. All right, now things are going to be a little tricky. There are different cases here. Let's do this case right here where it's 19, which means that rover is pointing to the first element. So what do we need to do?
Well, first element has an intent point to it, so you're going to have to deal with that.
All right, so let's go ahead and actually test this. If mhead equals rover,
Then you have to move the inhead pointer to where the next one was pointing.
right. First case, rover is pointing to the first element. We test that by seeing its head. So then, yeah, mhead would need to equal. How do we make mhead point to the next one? Actually, mhead dot. No, I'm sorry. Mhead equals. How do we make mhead point to the next one?
Can you do rover plus 1?
Close.
Double arrow.
Rover. Oh, well, we haven't used this one, get next. So it's going to go point to the next one. So in this case, what's going to happen is, let's see, we have our SLL node, star rover, and he's pointing here. We ask our rover and mhead pointing to the same memory location because they're both pointers. The answer is yes. So in this case, we jump to the if statement, and we have mhead is now going to equal to rover dash next, which will do that. Okay. Anyone think of another problem that may occur?
If it's one, or if you're trying to remove the tail.
Right, what if it was a one element situation? Mhead was pointing here, and tail was pointing here, and rover, of course, is pointing there. So in our code, we have mhead point to rover dash next, so mhead would point to null. That's exactly what we want. But what's the other thing we need to check?
You need to move the tail.
But hold on, we only want to move mtail if it's at the end. How can we check if mtail is at the end?
If the pointer on the element equals null.
Sure. Well, if rover, mtail is always going to point to the end, no matter what. So we will really need.
If rover
Yeah.
is equal to null.
If rover is equal to, okay, yeah, I see. That'll work. Well, the thing is, if we're moving, let me ask it differently. If we're in the test case, or the case where we're moving the first element, and the first element is null, and the first element is the only element, then mtail needs to point to null. So we need to also check if there's only one element. So I think that's what you were trying to say. I don't know. So if rover get next equals null, mtail equals null. If the linked list has only one element. Only one element, and we're removing the first element, then mtail needs to be null.
Well, doesn't that also work for like 75, because that's the end?
Now, if we are removing 75 here, mtail you don't want to point to null. You want mtail to point to 13 because that's what's at the end. But we're not to that point yet because we're going to try and handle a simple test case first. I'm trying to do this from simple up to hardest because it can get a little tricky. Okay. And then now that our pointers are set up correctly, in this case, mtail doesn't need to do anything. Over again, mtail is pointing to null. Now what do we do?
We need to delete it.
Yeah, let's delete it. Okay. All right. So that was with 19. I'm going to go back up to the board. I don't want to change all this, so I'm going to erase that. 19. Let's do 17. So rover 19, not there, so we're going to update rover to point to the next one. And let me think about this for a moment. This one's actually harder. Let me do the easier one, which is if 75. All right, there we go. Because it's 19, not there, 17, nope, 20, nope, 13, nope, 75. We're going to remove 75. All right. Else if rover get next equals null, we are removing the final element. That is not head. because we've already tested if it is head, right? So we know it can't be the head. So we're removing the final element. It's not head, so that means there's at least one more element in this linked list. How are we going to do this?
You make the element before point to null.
Right, so we want this guy to point to null, but can we get to the previous from here?
Make it go
Oh.
back.
One second.
Instead of a get next, make it go back one.
Well, then we'd have to store a pointer going back,
Oh.
which is called a doubly linked list, which can be very helpful, huh? Whoa. But we're not going to do a doubly linked list, we're doing a singly linked list. By the way, that's what your lab is do all this before a doubly linked list. Yeah!
Yeah.
Yeah! Right. So we can't go back, we can only move forward. So does anyone have an idea what we could do instead?
You make 75 a null. Instead of
And-
having a value, just make it a null.
I mean, we could have a point to null, but then you'd have 13 still pointing to a 75 that's out there somewhere, because you only have this guy who points here. If you have rover equal to null, problem is if you set rover equal to null, like you type it in this piece of code right here, all it's doing is this. These two pointers are still up there.
So you can't change the 75 value to a null
You
value?
could change 75 to 0, but then how do you know that your linked list wasn't supposed to hold 0? You have to delete the node. We need to delete the node and update the pointers accordingly. Anyone have an idea? This is a little hard.
You can have another node that like records the node before.
Right,
the-
so we need to have a previous. I'm calling it previous. What were you calling it? The node before or?
I mean, I didn't say it specifically.
Oh, okay, so we're gonna call prev. And the idea is that prev is always gonna point to the node before rover. Okay? In order to do that, we're going to need to update our for loop. Also, we need to actually create a prev. And where should prev start? We're gonna have it start at null, because if it's previous to head, it's not pointing to anything because nothing's previous to head, right? All right. Luckily, this isn't that bad, because you just have prev equal to rover, and then you're done. So right before you tell rover to go to the next thing, you have prev record where rover was pointing or is pointing, and then that way you always have two pointers, one to the previous and the other to rover. Okay. Oh yeah. Everyone tracking on that one, because I kind of just zoomed right into that. Okay. All right, now we have a prev. What do we need to do now? I'll let y'all start typing. Well, it's the final element, right? Where should mtel point to?
Right.
Right. So someone type that mtel equals prev, basically. And I'll update this on the board. I'll call that step 1. Then what do we need to do?
Make prev equal or point to null.
Point to null. So step 2 is to get rid of that and have this point to null. So I'll call it step 2. And then what do we do? Yeah, so finally you want to actually delete this. All right. Let's see what we're doing. Solid guesses? This unfortunate syntax will not work in C++ because I'm not returning a reference to it. But that's the syntax you meant. But great. All right, so now that that code is up there, I'm going to go on the board, and I've showed you what would happen. I would erase all this, but I don't want to lose, whoops, that's not what I meant to do. I don't want to lose all of this, so I'm going to go here, do that, and we're going to get rid of this for now.
Yeah, at this point it's starting to look a lot like a mess.
Yeah, I don't want to,
It's a spider web. What do you do?
yeah, when you have too many arrows, things go bad. Okay. All right, so I've restored it back to where we were. Great. Now, let's see. Let's try and remove the 17. Okay. So rover is here, and then prev is at the 19.
Don't you need to change the head pointer?
Thank you. I wonder how long that was wrong.
I don't know if you figure it out yourself.
I never told you intelligence is inversely proportional to the distance from the chalkboard or the board?
No.
No?
No.
Oh. What you can understand in the front row, you can write a book about in the back row, but you can't make a coherent sentence while you're next to the board.
Huh.
It's weird. I just have so much experience that I'm getting at least around the I can make coherent sentences part. But I mean, I'm sure y'all two back there, you could write books on this all day long. As long as I don't ask you a question, right?
No, genius. They know everything about everything.
Right. That's just how it works. Where are we? Oh yeah, removing 17. Thanks. That was a nice diversion. All right. So rover's pointing to 17. Prev is pointing to the 19. We want to remove 17. Let me go ahead and set up that statement. And we're just going to assume that that is the final else. Okay. What do we need to do? What's probably the first thing we need to do?
Wait, why is that net pointing to 19 though?
Because that is actually who's up front. I just messed up earlier. When I was removing, I didn't restore my end head.
Okay.
Yeah, restoration. Okay, we're removing the 17. We have rover pointing to the 17. We have prev pointing to the node 19, which precedes it. How are we going to remove the 17? What should we do first? Ooh, are you typing it? Yeah. Wow, look at that. Nice. Nice. So step one was you go to prev, you set prev's next equal to rover's next. Boom. Hey, look, you just skip over that element. And then once you skip that element, you delete rover. Oh man, that's beautiful.
I thought you said that one was harder.
I lied.
That's
No.
the best lie you've made all semester.
For y'all, apparently it was not harder, but a lot of times with students, they stare at this forever, and they just cannot get past the point that 19 needs to go around the 17. Like it just. Yeah. Anyways, I'm sorry because I'm sure there were a couple of you that what I just did not make any sense.
See, if your worst lie is that something is difficult, then I think you did pretty good.
My worst lie? I'm sure I got some worse ones coming around. Yeah,
Well, it's
or
worse
better.
as far as this class goes.
Okay.
No, it's gonna be that the next line is easy.
I never say that. Never say that.
Well, it will be accurate to say that it's easier than this one.
The next one.
I can pretty much say that all your labs will be easier than Project 1, except for Project 4 will be harder than Project 1. That's been pretty much consistent. Every other project and assignment, if I had to rank them from, was it difficult to easiest, I would say 4 is the hardest, although not by much. And then and then comes project 1.
What about
And
the final?
oh, well, if you do your labs and I don't know.
If you do the thing.
If you
it
if you do what I tell you to do and you get good grades, the final, most people do well in the final. It's not, if I guarantee you're going to do well in the final, it'll bite me in the back, right? You know, in the future or whatever. So I can't say that, but just do your labs. It'll prepare you for the final.
Just do the thing.
Just do the thing and the stuff. All right, what are we removing? Let's remove, which one did I try? Oh, 17. I love this. All right, let's save that. Oops, someone tried to start. Let's see. Hey, look, it got rid of the 17. So we have some confidence other things are working. We definitely have to write more test cases, but hey, look at that.
This test case is fine.
This
It works.
This one works. All right, let me go and fully update this. There, we removed 17. And yeah, is that all the functions we have? All right, so at this point in my normal lectures,